Alright guys, so today we're going to be talking about the oxymercuration demercuration reaction. And this is where we have an alkene and we react it with mercury acetate and water all over sodium borohydride. And the reason why we include sodium borohydride in the reaction is we'll see it later in the mechanism to obtain our final product. Now our final product is here, where our alkene is gone and instead we have an alcohol and tied to a hydrogen right here. So here is the mechanism as follows. So in order to understand what this AC means here, which is acetate, I'll draw out the molecule for our first step, but I'll use the abbreviation later on to save time. So our mercury is right here with a lone pair. And then we have our oxygen and then our acetate. So our acetate is a functional group. So what's going to happen here is there's going to be 3 arrows for the first step. Our carbon here will grab our mercury, or this alkene technically, and this lone pair will grab the other side, and one of these bonds will break, like that. And so what happens now is we have our structure here that looks like this instead. Our methyls, and then we have our oxygen here, and then we're going to draw AC to basically abbreviate for this part of the molecule. So therefore, our mercury has a positive charge. Now what happens is we can bring in our water, just like this, 2 lone pairs, and it's going to attack one of our carbons and break the bond between a carbon and mercury. Now, because this is a symmetrical molecule, as we see up here, it doesn't matter where it would attack. However, if this carbon had more than one methyl group, then it would for sure attack here because this is a Markov-Nikov reaction. And essentially what that means is our functional group has to be attached to the more substituted carbon for stability reasons. So now what we have is this molecule that looks like this. Our mercury is here, our oxygen, and our acetate. And then we have our water here, positive charge, and our methyl group. So now what's going to happen is we're going to bring in this part of the molecule that we had removed initially, right here, and it's going to have a negative charge on the oxygen attached to the acetate. And so this is going to take a hydrogen here and move those electrons onto the oxygen. So now what we get out of this, I'll draw it down here, is our alcohol, our methyl group, and our mercury bond to our oxygen to our acetate up here. And so now what happens is we're going to bring in our sodium borohydride. And this is one of those rare occasions where we actually don't need to know the mechanism step for this because it's beyond the scope of this reaction. So what we need to know is that once we react it with sodium borohydride, our carbon-mercury bond won't be intact in our next molecule, and instead it'll be replaced with a hydrogen. And therefore we have our final product. So this is the oxymercuration demercuration mechanism and reaction. Have fun with it. I hope this helps, and I'll see you guys in the next video.